Cognitive load theory was first introduced by John Sweller in 1998. Cognitive load theory divides memory into two different parts: working memory and long-term memory. Cognitive load theory tries to explain the limitations of working memory and how this relates to long-term memory. According to Heck, 2017, cognitive load theory says that because short-term memory is limited, learning experiences should be designed to reduce working memory load in order to promote schema acquisition. Cognitive load theory is a theory that tries to explain how people learn. It has several implications for teachers and instructional design. According to Spector et al. 2014, there are three different types of cognitive load. Intrinsic load deals with how naturally difficult the material is. Extraneous load deals with distractions from the learning environment due to poor instructional design, bad lighting, poor auditory, physical needs of the students such as hunger and sleepiness, and technological malfunctions. Germane load deals with how hard a student has to work at schema construction. The implications for cognitive load theory on education deal with the goals of limiting distractions and in teaching students at a rate that challenges them but does not frustrate them. In 1956, G.A. Miller proposed that people can only hold between 5 to 9 digits in their working memory at a time. If we apply this theory to education, it tells us to limit the amount of new information that we expect students to learn in one lesson. If we go beyond what students can absorb, then the extra material will be totally lost. This leads to the idea of focusing in on a few key concepts in each lesson. Cognitive load theory also reminds us to keep lessons short, minimize distractions, and break intrinsically hard information into smaller, more palatable chunks. As I was learning about cognitive load theory, a few questions came to my mind. One relates to an effective technique that I have used when teaching elementary students. I have noticed that if I give young students something simple to do with their hands, such as color a picture, it increases their ability to concentrate on pure auditory material. This makes me wonder about the interplay in cognitive load between information that students take in through their different senses, such as visual, auditory, or kinesthetic. Another question that I have is whether or not students with ADHD have different ability levels for dealing with cognitive load. Research done by Koffler et al. 2009 suggests that students with ADHD can reach peak levels of cognitive load even more quickly than students without attention deficits. This is an exciting area of neuroscience with many important applications to instructional design.